As you can see, looking at this graph of orientation length versus students infected, in order to minimize student infection rates, orientation needs to last 1 day. Realistically, a 1 day long orientation sounds pretty far-fetched, so instead we encourage an orientation length on the shorter side of 20 days. Now this might have seemed like an obvious result. Clearly, the sooner you introduce a quarantine, the fewer people will get sick. However, if we look at different values of the quarantine effectiveness, we actually see scenarios where it will be more effective to have such a long orientation that the freshman class has enough time to get sick, infect one another, and recover, all before the upperclassmen even arrive on campus. This is something like a 60-day long orientation for a 1% quarantine effectiveness rate. To answer our initial question, the school should have a shortest possible orientation length in order to minimize sickness, so that the upperclassmen can introduce quarantine right away. However, if we have a very, very low quarantine effectiveness rate in the 1% range, then it will make more sense to extend orientation. Hopefully, though, we wouldn't have such a low quarantine rate. We think it's pretty unlikely that the school would have a 1% effectiveness rate, even given the expense of quarantining students as well as the difficulty of determining who's sick. A 1% rate is pretty low, so we think that overall it's best to have a very short orientation to minimize student sickness. To wrap up our results nicely, we decided to run the SIRQ model one more time with the rate of alpha at 2.5% and our quarantine length at 7 days. To put all of this into perspective, the total number of students who recover is still under 50, and overall that's not that bad considering the intensity of the disease which we created. We also feel it appropriate to quantify the limitations of our model. We chose our values of the contact rate and the recovery rate that would give us a quote-unquote bad plague, but this wasn't based on any real disease. It was adapted from the information we did in the SIR model in the book. Since these numbers are very controlling of our results, changing the information for the plague would drastically alter the model, and therefore this information is only accurate for the specific model which we ran. We tried to ensure that the rest of our model was very specific to what we were working with, choosing an alpha based on the diminishing return of our quarantine effectiveness, but information like this still is subject to our recovery rate and contact rate, and therefore everything that depends on those two numbers could be completely arbitrary for any other model. In addition to the subjectivity of recovery rate and contact rate, it's possible that the downward trend we see in the total students infected is not because of the sickness running its course, but the semester running out of time. Given these results and our possible limitations, we feel very proud of the model we've produced and are happy to answer any questions you have about it.